what are the problems, what are the issues that might come up, and how we are going to handle with all those issues with the Patton units. So the NBN, as we all know, is rolling out. So, and then it would mean the NBN rollout would mean the end of sales for the PSTN circuits. So, and copper will no longer be supported. And that's what the NBN rollout means, that everything is gonna be an all IP network, a high-speed all IP network, and the voice traffic has to move to NBN media. And now this is, as part of the NBN rollout, this is going at a very fast speed, and it's time to act fast. So basically we have got Patton ESPC. So what it can basically do is it can simplify the migration process, or the process of how the NBN rollout would happen. So we offer a smooth migration path when people move inside NBN to an all IP network, and how they can avoid the complete overhaul of their PBX infrastructure. And while avoiding the overall complete overhaul of their PBX infrastructure, we can provide a seamless switchover with no downtime, and the additional value which these boxes can bring in is the fallback in case of NBN outages. Now this is basically just the outside view of the box. We will dig deep into it, and then how Patton SBC can help. Number one, it can connect the legacy PBXs with the ESPC. You can migrate to all voice over IP services over the NBN ecosystem, and you can retain the existing PBX infrastructure inside the enterprise network. So there will not be any interop issues, because we take care of the interop towards the northbound as well as the southbound interfaces for an organization. So, and there will be no change in user experience, because when we talk about the northbound interfaces, we will connect to NBN over the NBN network to the service providers, and there will be no change towards the customer side, and it is a future-proof solution. So with NBN, everything is moving to a voice over IP, and Patton is the roadhead for this kind of services. How do we do that? Like what actually happens, and how we can do it? So this is just a very basic idea of how the customer premises right now looks. So customer premises, they have got a PBX setup. It is connected over PSTN line to the telecom core network, which could be Optus, Telstra, or Vodafone as of now, or the the other vendors which are available on top of these like service providers. So they are providing the core PSTN infrastructure to the users, to the PBX setups at the customer premises right now. So with the NBN mandate coming in, and with the NBN services being provided to the customer, we have got NBN edge devices which are sitting at the edge of the network, and they are providing all the internet services to the end customers. So, and on the other side, the telecom core network, they have now started providing SIP with the NBN coming in. So that is the first step when we talk about moving to an all IP network. Now, when we have got SIP trunks available over the NBN, so the first thing which we do is, like, in order to do a seamless migration or a seamless no downtime migration, we simply insert the Patton box inside the existing PSTN network. Now what that does is, it basically would not mean any change to the existing customer infra, but the moment we have inserted this box, the second step is we can connect this box to the SIP trunk on the other side. Now when we connect to the SIP trunk on the other side, we are actually saying that, okay, the network on the PBX side, on the PSTN side will remain exactly same. We are just adding another SIP trunk to it. And then when the PSTN lines are gone, or when the PSTN lines are switched off, so we can move to we can move to a SIP architecture toward the northbound interface here. So basically from this Patton box, as you can see, the traffic will all flow over SIP, and towards the customer side it will be still the PBX setup which they already have. They won't have any change in their user experience. Everything would remain the same. Now NBN, we might see outages. We have seen outages in NBN. Okay, so when there is any outage of any sort of not on NBN, but it could be the outage which could be because of the service provider which are providing services on top of NBN. They might face some outages. So in that case, this box provides a 4G backup so that you can, in case of any outage of the internet, you can connect over this 4G interface to your SIP provider. And then when this PBX setup on the customer side changes to an IP PBX or to an hosted solution, so this box can still connect to your SIP to SIP network. It can create a complete seamless network for the users who are sitting on SIP network inside the organization, and to the SIP trunk on the outside. Now here normally like people come up and say, okay, why do I need a box when it's going to be an all IP to IP scenario? The first thing which I've just explained, okay, it actually provides a complete migration path. And once this migration is done, okay, then we talk about a complete SIP trunk migration. Okay, people say, okay, my network is all SIP now. What next? Okay, we can see that we know that PSTN is a reliable, is a good service, but when we start talking on voice over IP, people talk about security. Okay, what will happen to my network when it is going to be an all IP network? Okay, what will be my security? What will be the service quality? What about survivability? Okay, whether my network will be good enough, whether I'll be receiving the same kind of like network fallbacks and other stuff. So this basically box answers these questions. How do we answer it? So first of all, when we talk about security, we know that SIP is the most widely used voice over IP protocol, and thus it's the #1 choice for hackers to attack a SIP network. And they can commit various things like toll fraud. They can just start bombarding your network with SIP messages, which would mean like denial of services. And we have seen a lot of denial of services attacks in Australia over the past years. Even like we have seen it some time back when these denial of service attacks happened on our government services. So then some people say that, okay, these things can be just controlled with my firewall. I have a firewall. My firewall can control all these things. But then the firewalls are normally optimized for data traffic. They don't have enough performance for small voice packets, and they don't support and recognize SIP and RTP traffic. And normally, like when we talk about like small organizations or those places, like people, they say that, okay, we have got a modem which was given by a service provider, or a router which was given by a service provider, and those has got firewall inside. Those are like the small devices which might not be enough for having a good security for your SIP network. Okay, and hackers, even if we have got this firewall, okay, hackers can commit toll fraud by hijacking this SIP service. They can listen to your messages, and they can place unauthorized long distance calls over your network. So this would mean that they can come up and charge like thousands of dollars within a few hours. And this is what we have seen. This is what we have been like looking around. We have been we know that the amount of toll charge, the toll fraud damage is actually more than the credit card fraud. It's almost like twice the damage which people can do to a credit card. So normally the firewall which like the end customer put inside, it will not protect from the toll fraud. But if we put an ESPC inside this network, Okay, ESPC can provide security. It can definitely, it is definitely made for the SIP network. It acts as a back-to-back user agent. It can filter out your traffic. It can provide the denial of service attacks. It has got advanced call routing security. It can open up all the SIP parameters, and it can see, okay, which call should be allowed, which DID should be allowed, which should not be allowed, what kind of calls can be made through my network, all these things. And then on the denial of service, it can have the whitelisting. We can have like trusted peers that, okay, I will only accept call from this particular IP address or from this particular service provider addresses. Or we can have a TLS SRTP security setup. Okay, we can have a TLS communication for the SIP towards the northbound side, on the southbound interface towards the customer side PPXs. It could be plain simple SIP RTP. And then we do have SIP packet flooding prevention, wherein the moment like somebody tries to flood our SIP traffic from outside, okay, we can minimize it. We can sense that traffic, actually, not minimizing. We can sense that traffic, and we can dynamically stop those particular IP addresses to not push any further traffic. We can block them for a certain amount of time, or we can block them altogether. Now the next thing is survivability, which I have just discussed in my previous slide as well, that in case if like somebody starts taking something on the road, and then the NBN network is down, okay, so there's no internet link, not reachable from outside, and the enterprises might end up losing businesses and money. So when we have got this Patton device in the network, okay, the 4G backup which it provides an alternate route for the traffic, for the SIP traffic, and it provides over a cellular 4G LTE interface. So basically it has got a USB interface in the back. You can plug in any 4G dongle into it, and the device should be able to connect to your telecom service provider over the 4G network. And then the next thing is the quality of service. So normally this is a typical example of how this entire thing is happening in Australia. Okay, we have got internet service providers. Now these internet service providers, they are using the NBN backbone to provide internet services over the NBN backbone, and then on top of that we have got this over-the-top SIP service providers. Now these over-the-top SIP service providers, they cannot control what kind of data, or what kind of what kind of service policies and what kind of firewall rules have been defined by the internet service provider. And when somebody is kind of like downloading something or uploading something from the internet traffic, they are actually creating, they might be actually creating a bottleneck for the SIP traffic. Now SIP has to be a real-time traffic, and when we have these bottlenecks, okay, then the traffic can have problems. And then with this ESPC in place, we can monitor that traffic. We can provide a quality of service on top of that traffic. We can look at what kind of traffic is going through the network. When I say we can look at the traffic, we can basically classify that traffic, and we can provide a better quality of service to the SIP traffic, and we can give SIP traffic priority over the data traffic. And we do like proactive traffic monitoring on the box, and like people would still say, okay, do I need an SBC? No, people say, no, I don't need SBC. I can do phone calls without an SBC. I can have my SIP phones also provide like security features. I've got like fiber access link, and I've got a huge data bandwidth, so I don't need any QoS. But SIP phones, they do not protect you against all fraud, as this can happen inside the network. Okay, in case if somebody enters your LAN network, or some SIP traffic enters your LAN network, okay, the SIP phones will not be able to will not be able to provide you with the security in that case. So, and then even with a lot of bandwidth, okay, the access links, these can be saturated with large data file transfers, or somebody is playing the video, somebody is watching something on YouTube or something like that. Okay, there can be a huge data transfers, and the access link can get saturated very easily. And then the second link can prevent the downtime. And even when we talk about these SIP phones, okay, these can provide some security features. Now, if you have got 100 SIP phones in your organization, you won't be going and like configuring everything on all phones, and even a breach on one single IP phone, okay, would mean that the security is compromised. So should I go for an SBC? Yes, you better do so, because SBC, what we have all discussed, it can definitely provide an edge to customer when it comes to security, survivability, or to the service quality. So, and then it can do as less as like $500 to start with. Okay, now just to give you a brief idea about the Patton portfolio of the products which we have. Okay, so we have got SN5200, which is based on our old smartware operating system. We have the current operating system Trinity, on which we have got SN5300. Now this is basically just an ESPC. Then we have got SN5480, which does offer transcoding, 5490, which offer additional fiber and EFM interfaces. We have got SN5530, which can start offering you the PSTN ports, the digital BRI ports. 5540 series, this can offer the analog ports. 5550, this is a hybrid device which can offer BRI with FXS, or SN5570 series, which can offer you 1 to 2 PRIs. And then we have got the other devices which can, in case if you are interested in going for more than 2 PRIs, so we have got other SN4980 and other series of devices which can also offer you like more even interfaces. So just on the overall, so it's a smart choice for SME, very cost effective compared to the other market players. So the session border controllers from ECME or from Cisco, if you start comparing with them, it's very cost effective, it's very reliable. We manufacture our own devices, and so we know like how to make our boxes more reliable. We are not like dependent on any third party to do all this tests and stuff. We know we have been in the market. We can interop with we have already done a lot of interop with the major soft switch and IPPBX vendors. So we have got more than 1,000+ scenarios tested and passed for various kind of deployments. As I told you, we have got our own in-house production. All the products are engineered in Switzerland, and we have got RMA rates which is less than 0.5%. So with that, I would move back to you, Scott, so we can have some questions, and Brett and me, we would love to answer those questions. So I think we still have a few minutes, and we can take some questions in this time. Scott, over to you.
Fantastic, Jagdeep. Thank you very much. Appreciate that. Okay, guys, so we've had a few questions that have been answered already through the question and answer panel. But if you do have any questions that you'd like to bring up now via audio, just raise your hand on the GoToWebinar panel, and I'll unmute you, and you can ask those questions to the Patton guys.
Okay, Scott, I have got like one question here, which is the difference between smartware and Trinity. That's one question which has been asked by Darren. So, so Darren, like this smartware and Trinity, smartware was our old operating system. We have moved to Trinity a few years back. So Trinity and smartware, they do coexist, but the way forward is like Trinity, where we support the session border controllers are based on like Trinity, most of our session border controllers, and that's the way forward for our all new deployments. And and it's actually a very exciting thing. So in case if you need like more information on like Trinity and Smartware, like the differences and what we can do, so you can even like there's a link on our website which would compare the features between like Smartware and Trinity, and I can also send you some more links on that. So then the other question which I see is, do all models have the ability to 3G, 4G? Yes, most of the SBC they can provide you with a 4G interface. So we have got USB. So with the USB you can plug in any third party like 4G dongle, and you should be able to connect to the network with that.
Okay, Jagdeep, there's another question there in regards of, this is from Paul, in regards to QoS. So in relation to QoS, is the modem router already set up for QoS for VoIP? How does that work with the SBC QoS?
Okay, so with the ESPC QoS, what we can do is we can define the class of service, we can define type of service when the packet goes out from the pattern. So in case if the modem or the router, okay, it can sense that QoS, definitely they can work in tandem. Or in case if it is unable to sense it, so you might have to end up like switching off the QoS on the router. Or because like when we talk about like one device is sitting behind the other, okay, so basically modem router is sitting at the edge of the network if you are putting ESPC behind that device, okay, or you can set up like a DMZ or something like that, wherein we can control our own QoS. Okay, so it can coexist in tandem. I think I can take that this question. I have few slides on this one in the technical session, so I can definitely like give you more details there on this one.
And Jagdeep, Paul also asked if it's configurable or it's just automatic for the QoS.
It's very much configurable. It's very much configurable. You can define what kind of traffic you want to pass through the box, okay, what kind of priority you want to set, so you can definitely do that. So there are close to, I think, 22 parameters based on which you can define the type of service, the class of service. Not only just that, basically you can define the ACLs and the service policies based on those parameters.
Okay, we've got a couple of questions here from Darren. So firstly, Darren, you've asked about NFR products. Yes, Alloy is able to provide NFR products. If you just contact your account manager, you'll be able to discuss that with them. If you don't know who your account manager is at Alloy, just shoot me through an email and I'll pass you through to the appropriate person to help out with NFR pricing. And then Darren's also asked about the USB dongles that are supported on the Patton device of Jagdeep. So do you have a list of supported dongles?
Yeah, so basically we have got Qualcomm like chip inside. So basically most of the vendors, okay, which is like Huawei, or it could be like Sierra Wireless or the Novotel Wireless. So we support those guys. Okay, we support all the major vendors who provide these dongles to the service providers. So just in case if you figure out any dongle which is not supported, okay, we will be happy to look at that, and we'll be happy to like make it working on the Patton device, because you can, like there could be like thousands of dongles in the market. Okay, we are definitely open to look at any dongle which you do not see that, okay, there's no support for that, or you're not able to make it work on the Patton unit.
Fantastic, thank you, Jagdeep.
And there's a list available on the Patton website, so we have all the major vendors supported there.
Perfect. All right, guys, is there any other questions that you'd like to ask? All right, now before we do finish up, just a reminder that we do have the technical additional webinar coming up on the 27th of July, which is basically a in-depth technical overview of the SBCs. And again, we kind of follow on from today's webinar, just in a more technical sense. So if you do want to register for that webinar, please go to the LO website and go to the events section, and under the webinars tab there, you'll be able to register for the webinar, and that is on what day is it? Thursday, I think, Thursday 27th of July at the same time as today's webinar. Okay guys, if there's no more questions, I think we'll wrap things up. Jagdeep, is there anything else that you would like to add?
No, that's it for now. Thank you, everyone. Thanks for being on the call, and then I will do it back to you.
Okay guys, we just appreciate you spending the time today. If you do have any questions, feel free to shoot. You can send me through an email, and I'll do my best to answer the questions. If I need help from Jagdeep, then I'll definitely forward your request through to Jagdeep. Okay guys, once again, thank you, and we'll talk to you all soon.
Thanks, everyone. Thanks, Scott.
Thank you. Bye-bye.